about triangles. So,
Well, they added 20.
this part you might remember. What kind of, let's start with this. If all three of these sides are the same, what kind of triangle is it?
Equilateral.
Equilateral. Okay. If just two of the sides are the same, what kind of triangle is it? Isosceles. That one's harder for people to remember. All right. And if no sides are equal, it's called scaling. So isosceles is two equal sides, and equilateral, this is the one people remember. Three equal sides. It's got equal in the word.
Is that all we need to remember?
No, for now. I mean, we just started, but that's the first part of what we need to remember.
So,
Also, this is, like, if you turn your page back, it's in your book. But okay, that is based on how many equal sides there are. 3, 2, or none. All right, those are the three options. Now, the other way to classify triangles is according to what kind of angles it has.
Acute triangle.
Okay,
Obtuse.
what are all three of these angles in this picture?
They're cute.
They're all acute. So this is called an acute triangle.
Are we hitting on triangles now? Isn't it? We're not allowed to do that. We're
Okay.
Leviticus 18.
shut up.
What kind of triangle is this?
Right angle.
Triangle.
Okay, if it has one right angle, it is called a right triangle. Okay, it could look like this, could look like that, right? Those are both right triangles. Notice the two, what kind of angles are the two not right? Acute angles. So it's got one right angle, two acute angles. Do you guys remember what the angles of a triangle should add up to? 180. So is it possible to have two 90-degree angles? No, because together they make 180 and there's nothing left for the third angle. Yeah.
How did you say we know if it's an acute angle?
If they're all smaller.
If they're all acute angles, if all three are acute angles, it's an acute.
Equilateral triangles are acute.
Okay.
Seems like it would need to be a right angle.
No, they're not right angles. Like they could all be like 60, 60, 60, or 50, 60, 70, or something like that. There's no right angles in there. See the difference? Yeah. And then, which one have I not drawn? Do you guys know?
The obtuse.
Obtuse. So an obtuse angle, looks like that. It might look like that. Has one obtuse angle in it. Obtuse triangle has one obtuse angle in it. What are the two non-obtuse angles? Acute. So if you have something bigger than 90, the other two have to be less than 90.
If it's something equal to 90, the rest have to be.
No, they have to be less than 90. Can't have two 90 degrees in the triangle because that leaves nothing for the third angle.
So could you have a obtuse triangle and like the obtuse part could be like 179 and then the other two be like a half?
Yeah, well, if you draw a 179-degree angle, I mean, it almost looks like a straight line, right?
Yeah.
So it
Oh.
would be really hard to draw.
Yeah, that's
I can't really do it.
I'm an artist, so I can draw. Yes, you are very artistic. Autistic.
Okay, so you can name them, you can classify them according to both. This is an equilateral triangle and a what?
Hope you feel better.
This is equilateral and it's what else?
Acute.
Right, so this is an acute equilateral triangle. What kind of isosceles is this?
Acute.
It's acute isosceles.
Yeah.
We're gonna learn this later. These two angles are the same.
Always
You're
good.
Okay, this is an isosceles. What else? What kind of isosceles? Obtuse isosceles. 'Cause it's got that big angle.
So are the two acute angles always the same?
Huh?
Are the two acute angles always the same on obtuse and right?
No.
What happened?
Okay. What about this? Scalene and what else?
Right.
Well, this is not quite 90.
Like, it's like angled for me, so
It's a little bit. It's like 70, 75.
Oh, the bottom and the
Or
left
8,
side are the
88.
same, right?
85. No. So all these sides are different. All these angles are different, but they're all acute angles. So it's an acute scalene. This would be a what?
Right.
So when there's multiple lines.
It's a right
Scalene.
scalene. It's a right scalene. So one right angle, 3 different sides. Okay. All the angles add up to 180. What are we doing here? Alan, what are you doing?
Drugs.
Put that away. All right. Let's see. The acute angles of a right triangle. Well, yeah. In a right triangle, if this is 90, what do I know about these other two angles?
Acute.
Well, together, what do they have to be, though?
180.
190.
They have to be 90 together. So the two acute angles, because together 90 plus 90 equals 180, right? So the two acute angles in a right triangle have to be complementary,
Yes.
right?
Exactly.
The two acute angles in a right triangle have to be complementary.
Mr. Jordan, thank you for letting us skip the proofs.
In a equilateral triangle, if all the sides are equal, it turns out all the angles are equal. So what would the angles have to be in an equilateral?
All 180, but no.
Okay, listen. In an equilateral triangle, all the sides have to be the same, but all the angles will also be the same.
60.
So they'd all have to be 180 divided by 3, 60.
No matter what.
Well, yeah, if it's equilateral only.
And when, well, like, wouldn't X and Y on the right triangle have to be 45?
No,
They don't?
no. Okay, here's an example. That looks like it's maybe 20, which means this would have to be 70. That might be like 50 and 40 or something.
Are we ever gonna have, I'm assuming are we ever gonna have to use the, what's it called?
The protractor?
Diagram here?
I don't know.
The protractor.
Yeah,
No, I don't think it's gonna come up again.
yeah, cause that thing confuses the crap out of me when I see it.
All of the images they give us on the map are like too small. The protractor's like 2 times as
Yeah, I know, it's
They're all
like, you
aligned.
can't see where you're actually looking.
Okay, if I have a couple triangles and like this angle is the same and this angle is the same, and guess what else I know?
That
You know that the
That
other
big
angles
one's the
are the same.
Right, if two angles in a triangle are congruent to two angles in the other triangle, then the third angle would have to be congruent. Because they all have to add up to 180, basically. Okay, an exterior angle, does that come up? I think it does. Yeah. Okay. Yeah, this part people forget easily. I don't know. Maybe it's the visual.
Fun.
Gives people trouble. If you extend one side of a polygon, this angle that is created is called an exterior angle.
Yes.
Okay, not just triangles, but any shape, but we're just doing triangles right now. Exterior angle because it's outside. So I could like extend any of these sides, or I could have gone the other direction. That's an exterior angle. Well, how is this exterior angle related to the adjacent interior
It
angle?
add up to 180.
It'd have to add up to 180. So let's say angle 3 and 4 are supplementary, right?
Yeah.
They add up to 180. What do I know about angles 1, 2, and 3?
They add up to one.
They add up to 180. So if 3 and 4 add up to 180, and 3 and 1 and 2 add up to 180, what do I know?
Then
So it
1
are.
plus 2 plus 3 equals 3 plus 4.
No.
Oh.
Just two.
Okay, if 3 and 4 add up to 180,
And the other one,
and 3 and 1 and 2 add up to 180,
then one.
then 4 is equal to angle 1 plus angle 2.
Ah, yes. Very big brain.
Okay, so let me throw some numbers in there, then maybe it'll make more sense. Let's say angle 3 looks like it's about, I don't know, 650. Okay, what would this angle right here have to be?
120.
130, because it's 180 minus 50. Okay, what would these two angles together have to be? 130.
So 70.
Because this plus this has to add up to 180. So the exterior angle in a triangle is equal to the sum, you guys remember what sum means?
Addition.
Of the remote interior angles. What does remote mean?
Oh, wait.
Means far away. So these two angles are far away from this exterior angle. So these two angles equal this angle. I said a lot of stuff, but anyway, people have trouble with that one. Okay, number 1, you ready? Classify each triangle by its angle measures, and the side lengths. So there's kind of two answers to all these, like acute, isosceles, that kind of thing. Number 1, based on its angles, what's number 1? Right?
Right?
It can't be right and acute. If it's got one right angle,
Isosceles.
does it have any equal sides?
No.
No.
Oh, no. It's just,
So it's scalene.
I forgot you need the little red lines.
If it's got one right angle, it's a right triangle. It doesn't matter if the other two are acute, which they always will be. Number 3, based on its angles, what kind of triangle? Acute angles, acute triangle. Based on its sides, no,
Equal
equilateral.
Oh, great.
Technically, by the book's definition of isosceles, it is isosceles because it does have 2 equal sides. But a better name is equilateral because it has 3 equal sides. I think the book might try to trick you with that later on.
Nice.
Okay, number 5, we're supposed to draw our own. Acute, scalene. It says mark the, kind of like they did on 1 through 4.
How do you spell oh, never mind, I found it.
Acute, scalene. I kind of did that on my example. So acute means we have to make all the angles small. Scalene means we have to make the sides not equal. So I always just kind of like make it kind of a leaning tower.
That's
Okay. Anyway, all the angles are acute, and it's scalene because the sides are a little different. This one's a little bit longer than this one. That's a little bit longer than that. Those two are pretty close. Okay, number 7, obtuse isosceles. What would that look like?
They gotta have 2. It looked like number 2.
No, that's acute isosceles.
Whoa. It'd be
Okay.
like really long.
Number
Like
4 is
really-
obtuse, but which sides would have to be the isosceles
How is
sides?
number 4, how is that obtuse?
The top angle is bigger than any. Okay, it's the angles around the obtuse angle, or the sides around the
Looks like
obtuse
a mountain.
angle Well, it can be turned any direction. It could look like this.
Yeah, but it looks good now.
It looks like a mountain upside down now.
It looks like
Okay,
one of those mountains.
And you're supposed to mark the sides that are like congruent, so those two.
Mark. Like when you're a kid, you draw mountain range in the background, that's what it is. It's that.
Okay, number 9, we're supposed to look at that picture on the right. Name the legs and the base. Oh, I totally forgot about that.
They
So,
have legs.
in a right triangle,
Or
you guys remember back when we did Pythagorean theorem last year?
yeah.
What are these two sides around the right angle called?
A and B.
No. They're called legs.
They are.
And the long side, you probably remember this better.
That looks like the road.
The long side's called the what?
Hypotenuse.
Hypotenuse, yeah. Okay,
I see the legs now.
leg,
You
hypotenuse.
gotta draw the stick figure though, like coming out
All
of the
right.
legs.
In an isosceles triangle, it also has some special names. Guess what they call the equal sides?
A and B. Legs.
Legs. They're not original people.
I
Okay?
actually feel like A and B.
And the third side, the not equal side, is called the
Hypotenuse.
base.
Base, okay.
Up here, this angle that's between the legs,
Whoa.
they called it the vertex angle, which is a terrible name because all these corners are
Vertices.
vertices, but whatever.
So hypotenuse is the long side.
See guys, I know English. I know English very good.
Hypotenuse is the long side, yeah.
Very
I'm gonna
good
draw that,
English.
hold up.
Very good English.
It's probably in your book somewhere.
Cactus. Cactus.
Probably. Or not.
Nice.
All right, number 9, refer to isosceles. Okay, so they're telling us the triangle is isosceles, triangle MTS.
Oh, yes.
Name the legs and the base. So what would one of the legs be called?
Gerald.
Linus T.
Yeah, what she said.
Segment ST, right? So 9A,
Okay, he's gotta have an ST in his name, then I name him Stewart.
okay, what's the other leg?
SM.
SM.
I named her Samantha.
Shh, all right, we get it. Those are the two congruent sides. And then the base
TM.
is the not congruent side, so it'd be TM.
And Timothy.
Does that matter?
T.
No, it doesn't matter. Okay, B says name the vertex angle. What's the vertex angle?
S.
You can just call it angle S since there's only one angle up there. Okay, the base angles would be the angles next to the base. The base angles are always going to be the same, but they're down here by the base.
Angle M and T.
Angle M, angle T.
I named them Martha and Tyrell. The S
Okay.
made him stupid.
What do you notice about the base angles?
Which one?
They're congruent. That's always going to be true. We haven't really learned that yet, but later on we will. What?
I was just glancing at number 10 here. For the B section, express the relationship.
Yeah, we're going to talk about that. Okay, what's the relationship between the legs and the hypotenuse?
They
A
add
squared
one
plus
eighty.
B squared equals C squared.
Yes.
I'm a G.
But they put 3, 4, and 5, not A, B, and C. So what should it be?
So 3, 4, 5. Or like 3, wait, 3 plus 4 equals 5.
Now,
5 plus
3
4
squared plus
equals
4
3.
squared equals 5 squared.
3 squared
Oh, I forgot the square.
plus 4 squared. We're going to spend a lot of time on this later. Equal like a lot later, like second semester. 3 squared plus 4 squared equals 5 squared. And they said, what's that name for that relationship? Pythagorean theorem.
Do we have to put the answer for number A?
Why would you not
Yes.
put the answer?
You do have to do A. Number 11. Okay, so we're just finding the missing angles. Carolyn, how on 11? How can we find angle A?
By subtracting 65 twice from 180.
180 minus 65 minus 65, or 65 plus 65 is 130. So you could do 180 minus 130. So that'd be 50 degrees. Measure of angle ACD. Why are they using 3 letters on this one?
Because there's the line.
Because there's multiple angles at vertex C with vertex C. So you can't just say angle C. Angle ACD is what kind of angle did I call that? Exterior. It is obtuse, but it's an exterior angle to that triangle. How could I find an angle ACD, Sarah? Okay, what do we know about these 2 angles right here? Right, so what do I do? Yep. Which is, drum roll, 150.
I got 137.
Oh, there's
Good
two
job.
answers on these. I did not notice that part.
Okay, number 13, what do those 2 little red things mean? Means they're congruent. Okay, so they say we want angle KIH. How could we find angle KIH?
Well, we use the 140 and we find angle I, and then we also know that angle H is the same as angle I.
Nope.
What is bro? Yeah.
How do we find angle KIH?
Because since it's an exterior angle, you subtract 140 from 180.
Yes, it's what Sarah just did. 180 minus 140. Those 2 have to add up to. You said a lot of stuff. You didn't say that.
Yeah, it's-
Oh, I was finding angle K. Can I
Okay.
find angle K?
How do we find angle K?
So you take the 140, with that you find angle I, and then you know that angle H is the same as angle I, and then you find the addition of those, and then you subtract 180 from those since you know
Okay.
that the entire.
Because
That's
they-
so unbelievable.
Because they put red arcs down here, we know they both have to be 40. So these make 80. 180 minus 80 is 100.
Bro, you like, I don't even know. You just
all
did like
words in your
12 side
vocabulary.
quests and that fucking problem.
I know, that was the whole purpose.
The Koenig side device.
Alright. 15. On 14, how could we solve for x there?
S or X?
Dude.
Oh,
Wouldn't you have to
you
do like
you have 2x plus 2x plus x equals 180.
Right. 2x plus 2x plus x
Big brain.
equals 180. How about 15 though, big brain?
What?
What about 15? How could we find x?
Okay, so first you do 180 minus x, and then you find the measure of the angle n right there, and then you do all of that equals 180.
We don't know what x is.
I mean,
Oh no, why is it so long?
Okay. What kind of angle is x?
oh right, you don't know that.
It is an exterior angle, right? What was the very last thing we talked about? Exterior angles are equal to what?
180.
No.
Or what
They're-
are they equal to?
Shh, let's just listen.
They're equal to the
Ex-
sum of the
Remote. Exterior angles are equal to the sum of the remote interior angles. In other words, x is equal to angle L plus angle M.
Oh yeah.
You guys get it? x is an exterior angle, so it's gonna be equal to the sum of those two interior angles on the other side.
My way would have been.
So x equals x minus 60 plus x minus 20. All right, there were a few algebra failures on the test. Most of you got it right, but there were some.
Clayton, that's me and you, bro.
Well,
Yeah,
I don't remember if you missed that one or
they
not.
were
X plus X.
This is why they both failed.
2x, negative 60, plus minus whatever, negative 20 minus 80.
Okay, if we have x's on both sides,
Well,
Get rid of it.
yeah, mine's-
I say you subtract the x and then add the 8.
Eli.
Like a toddler, bro.
Oh, really? Works better.
Just never stops rambling.
So negative x is negative 80, so x is... Would negative 80 make sense on these problems? No. If you get a negative, something's wrong. We're talking about the angles in a triangle. So x is 80. That was basically this angle up here, right? 80 degrees. So how do I find these two angles down here?
Well, you can find the other one, which is
Plug in
100.
the 80.
Yeah. This one was x minus 60 over here. This was x minus 20. So 80 minus 60 is...
20.
And 80 minus 20 is... See, these two have to add up to that one. Get it? Alright.
Yeah, but couldn't you just like have put in 100 at the top and then went from there?
How would we know that's 100 though? We didn't know any three. We didn't know any of those.
Because the top one plus the one by is 180.
That's true, but we didn't know this one until we just solved it a minute ago.
I don't think there's any more question about it.
We didn't know it was 100 at the beginning. There's no way to tell. Okay. Well, there's only one angle that we don't know is right here. What's this going to be?
It's going to
100.
be 100.
Okay. Now we just got to kind of put it in order. The first question is measurement of O in L.
That's 80.
That was the 80. That was the X. Whoops. Second question is angle L, which is what? That was this one, 20. Third question is angle M. That was this one on the right. And the last question was the only angle we haven't mentioned yet, that thing right there, 100. L and M.
Oh gosh.
Okay, 17. '17 is the same thing, it's just they took triangles out of
18 is so
real life.
long.
Okay, can you guys, it's kind of hard for me to read it in my book. Can you guys see the triangles on 17?
It's like
There's supposed to be red lines. If I were to draw, I don't know if I can read it. D's at the top, A's on the side. And there's a 90-degree angle right there. What else? There's a B and a C right there. Okay. Is that all the info they give us? Oh, 130. Okay, well, that's what the picture's supposed to look like. It's kind of hard to see. But if this is 130, let's go ahead and do this, and then we'll fill it in later.
There's another
What's this angle going to be right here?
70.
No, it's not. It's going to be 50.
50. Because these two have to add up to 180.
The other one is
Okay.
going to be-
How about this angle right here?
Let's check my.
That's going to be
90?
This one's 90.
40.
Okay, there's
Wanna win?
a couple ways we could do this. These three have to add up to 180, so we could have done 180 minus 90 minus 50 is 40. Or the two acute angles in a right triangle always have to add up to 90. Because 90 plus 90 is 180. Anyways, the first question is angle DBC is what?
The C is 90.
DBC,
Oh no.
50. Angle BCD, that was the 90, that's the one they told us. BCD right there. And then angle BDC. BDC, that one's up there, is 40. Okay. Number 18 is basically the same thing but backwards.
Yeah, and it's super conscious. What even is that
It's
picture?
it's the yellow. They're highlighting the yellow triangle.
That's confusing.
Actually, there's another triangle up to
Yeah,
the left.
Yeah, there's three. I know that's what I'm saying.
Okay, 21. State the measure of the exterior angles of angle ABC.
I heard words.
21 says state the measures of the exterior angles. What do they mean by exterior angles?
There's no
When you draw a line.
There's no.
When you extend the line,
You have
and
to draw around.
so this is A, B, C.
C is 80 and D is 40.
Yeah, I mean, you don't really need a picture to do this.
You just subtract 80.
Right. So for A, angle A, if you extend the line, what's this exterior angle that's created?
It's supposed to be 180, but you have to like subtract.
Right. Together, the interior angle and the adjacent exterior angle add up to 180. 180 minus 60 is 120. Okay, and that's just going to happen on all these. Doesn't really matter which line you extend. What about that one?
140.
140.
I love C.
And then C,
101.
We should do that. I like those kind of.
100.
I agree with you, Stan. Why can't all math papers be like this?
What is 22 even asking? Equal.
What is the measure of the exterior angle of an equilateral triangle?
No, it's equal
Nah, it doesn't
to
say it.
Okay, do it on your own, do it on your own. It's what's the measurement, like how many degrees, that's what that means. Okay, 23, do it on your own. Where would you find,
Ah.
oh, I did put number 30 on there, did I not write 30 down?
No.
No, you really should. You know.
Wait, what about this? So is it asking? Wait.
Yeah, we're good,
22
we'll do
is
30.
Is it asking like what the extending line is?
Mr. Jordan, don't do it.
It says like.
You know you don't want to.
That's confusing. Do 30. Here, I don't,
Just add plus 30.
is that a real laugh?
No, that was so forced.
That's like her all
It was
history
a
class.
joke.
Her and Skylar all history class, bro. They be forcing laughs
Her
at
and
Mr.
Skylar. Who's her?
Or what's her face? The one you sit by.
No one to
Yeah.
sit by.
I
You
forgot.
forgot her name.
I forgot her name.
Okay, 23.
I forget Eli's name.
You can kind of refer to 21 to help you figure these out. Where would you find the largest exterior angle on a triangle?
The
Huh?
You have two things.
Okay, on our last problem, which of these angles
80.
had the largest exterior angle?
You
A.
have two.
Oh, exterior
B.
angle B.
Why was it the largest?
Had the
Is that
smallest
40?
interior
The
number.
smallest, adjacent to the smallest interior angle.
A is B and B is M.
C. All right, where? Okay, kind of the same question. Where's the smallest exterior angle going to be
Smallest
found?
Adjacent to
largest
the largest
adjacent.
interior.
I feel like we just did this, but we're opposite.
Let's see what the book wrote. They just put adjacent to the triangle's largest angle.
Mr. Jordan, you know what we should do tomorrow for class? No, we should listen to Are You Gonna Finish That Croissant for 10 hours straight.
Probably one of the worst ideas of my career.
Alright, we got an hourglass.
Oh, are we doing it together?
Angle LMNOP.
Now I know my abacus. Next time I'm using it.
Alright, so when we're trying to prove angle L is congruent to angle P. Okay, when we are writing our own proofs, what do we need to start with here?
Give it our
Statement.
Statement and reason.
And then give it.
It's just the way it goes every time, statement and reason.
Oh, it's pretty.
Okay, what's the statement gonna be?
angle L or angle N is congruent to angle L.
How did we know that?
It gives us
It gives us
I didn't know what
yeah, well, I messed up while I was talking.
Okay, we're trying to prove angle L is the same as angle P. What else do I know just by looking at the picture?
angle L is congruent to angle.
No, we don't know that.
I didn't hear what you said.
I said, what else do we know is true just by looking at the picture?
Oh,
P and
You
L
know
must be
that-
congruent.
No, we don't know that.
yeah.
I'm not gonna lie, no idea.
Oh, they're both sides are equal. Like
No,
LMN and then MPO.
L and N are alternate exterior.
say, what'd you say, Easton?
Like the top half and top bottom, or bottom.
And
This
they're
stuff
not
on the top
symmetrical.
of
No,
the
they're not
equal
symmetrical.
to
They're
stuff on the
congruent.
bottom.
What?
If you like take LMN and flip it,
It's
then
the
they're
same.
congruent. And that means LMP are congruent.
Not necessarily. Even the way I drew it, the bottom one looks bigger to me than the top one.
Give us something, Mr. Jordan.
I don't know.
N is the vertex.
I hate geometry.
There's something you should know just by looking at that picture.
N is the vertex.
It looks like triangles.
N is equal on both.
In the
N
number
is the vertex.
Yes, N is a vertical angle with the other one.
Okay, the vertical angles are congruent. N is not an angle.
Really?
You said is the vertex. That doesn't really tell me anything.
No, I said N is equal on both sides.
Okay.
But N is
Wait,
not.
wait, since you have
N is not an
two
angle.
angles and a triangle,
Angle-
that means the third has to be the same.
Yes. Angle LNM
I have some big brains.
is congruent to angle PNO.
Did I not say that like 12
You most definitely,
times?
you most definitely did.
Bro.
You were being very vague. You said the top half's the same as the bottom half.
But you know what I meant though.
No, nobody did.
I'm pretty sure you guys were talking about the triangles for a second.
No. I
Okay,
didn't.
what was the reason for this?
Let me find it.
Come
vertical
on.
angles
Alternate.
are congruent.
Vertical angles are congruent or vertical angle theorem.
That's crazy.
Alright,
And then I don't know what you call it, but since two of the three angles are congruent, the third has to be.
right.
I don't know.
So
what
one
you
of the things
call
we
it.
talked, there's no name for it.
Two and
If two angles in the triangles are congruent, then the third angle has to be
Yeah,
congruent.
exactly.
T
So you just have to,
L is equal to P.
no, we're just gonna say it. Angle L is congruent to angle P.
Well, how did we not know that was second? Our reasoning is sound.
two angles of one triangle.
Because we know if two angles in a triangle are congruent to two other angles, then the third angle has to be congruent.
Well, no, I mean, how do we know, oh, that L is congruent to P, why can't we have put that in number two?
Because we didn't know that the two angles in both triangles are congruent yet.
Interact with triangles. We should do that.
So, if two angles in a triangle, oops, why it's good to name the theorems.
What? I'm not putting that. That's crazy.
Because then you have
Yeah.
stuff.
Then I'm taking a point off.
I don't care. I'm not writing
You can't take a soul.
Yes, I can.
that. That is too much. You're gonna make my brain explode.
That's what me and Joe
He's
kept.
giving you the answer.
That's what me and Joe
God
kept
forbid we
changing.
write an entire sentence.
That's what me
Yeah.
and Joe kept changing
That's
at
where
the
that's
volleyball
what
game.
English class
They
is
can't
for,
take
not
us
math.
all.
Math is for numbers,
I'm
not
still confused.
big Austin.
So 22, what is it as? Like, I'm so